Welcome to EIP Editing Office Hour 7. I have shared the link for the agenda in chat. We are joined by a few EIP authors today. Sam, I have list of the proposal number or pull request number. If you would like to start, share your screen. The first PR is 6059.
All right, let's get this going. All right. Just get the chat open here. There we are. All right.
I'm seeing a black screen. Am I the only one?
Yeah, we can see Sam's shared screen.
Okay, I'll refresh. Be right back.
All right.
Mhm.
Okay. So what is a nestable? I think I've seen something similar to this one before. Let's see.
There is a very related one, which is 998, but we explain the differences in the
Okay.
rationale.
Perfect.
Sorry to ask this, Sam, but could you stop sharing and reshare again? I know it looks like
Oh
I'm the
yeah.
only one with the problem, but it's hard to be reviewed without.
No problem whatsoever. I know Zoom is sketchy sometimes. Any luck?
No, sadly no, but it's okay. I'll be watching it in another screen for now. Thanks for trying.
Are you in the desktop app or are you in the browser?
Browser.
You could try the desktop application. It's a little bit more reliable.
Yeah, we'll try next time.
Okay. Sorry, I haven't actually read this one yet, so just give me a few seconds here. Okay. So I'm still not sure if Mermaid actually renders properly on or like with our renderer. Okay. Just because it can also be a smart contract. Child token is a token that is owned by another token. A token can be both a parent and child at the same time. That makes sense. Child tokens of given tokens can be fully managed by the token's owner, but can be proposed by anyone. Okay, so. Okay.
Sorry.
No worries. So, how gas efficient is it when you have like really deep nested NFTs? Like if you have a like three children deep or something, does that end up like causing problems?
Sorry, make sure I'm muted here. Yeah. So it's actually not very different. I mean, we have compared the cost of our operations against regular operations for ERC 721s, and at most it's twice the cost. But it doesn't affect when you're handling children. It doesn't affect how many are there because that's why we use indexes.
No, no,
So
like the depth.
it,
Because so each child, so like if you have like a chain of like one parent, one child, who has another child, who has another child, but they're all managed by the owner of the very top NFT, right? They don't have their own owners. So
Yeah, so many operations are only can only be done by the direct parent, which is an NFT,
mhm.
like transferring. So in that case, you don't need to go much. You just go one level up. But for other operations, we do need to get the root owner. So it depends. Yeah, if you have more like more nested levels, you would have to call more external contracts to get the actual root owner.
Okay.
Uh, so yeah, there is a cost there which increases if there is a lot of levels, but it's really not like unmanageable.
Oh wow, we broke 6,000. I didn't even notice. Okay. Okay. Good. Yeah, so from a quick read, I'm gonna have to go through this again, like to get a bit more technical on it. But it looks really good. I think you know, you didn't hit any of the common problems a lot of people hit in their EIPs. So I will probably go a little bit more in depth, but yeah, it looks great so far.
That's great news. Yeah, we just recently sent the multi assets once, so we learned a lot from that experience.
Yeah, no, it looks
So
it looks also. What one question I should ask is, so what's the advantage over this of this instead of just setting the owner of an NFT to a contract? Like, why would you want to do this instead of that?
well, we put some of the use cases there, like bundling or membership, delegation.
Oh, right, right, but like, so I think both can implement the same thing, right? So you have a smart contract, and the smart contract owns the child NFT and allows the address that holds the parent NFT to interact. Like,
Hello?
Hey Sam, we lost you.
It's Sam who is gone, right?
Yeah, it's Sam. Pooja?
Yeah, probably screen. Sometimes Zoom gives up. So we should wait for a minute or so. Maybe he will try to rejoin. I'll check and chat with. Yeah, now he's gone. So I hope he will join back. Henry, you are new here. Do you have any PR number that you would like us to be reviewed? While Sam is joining, probably I can collect that and we can have it added. Sorry if we can't hear you if you're talking.
Can you hear me?
Now, yes.
No, I do not. I just saw that this was open, so I figured I'd sit in and listen.
All right, not a problem. Thank you for joining.
Yep.
While Sam is trying to reconnect, I think what he means is whether the author is considered the alternative options to use the contract instead of pointing the ownership to another NFT, and whether this consideration has been reflected in the rationale.
All right. Thank you, Victor, for jumping in. Yeah, that would be nice. Like, Stephen, if you have any other question or maybe have an answer for him, that would
Yes,
be.
I was lost. I lost the screen. But yes, I also think that's what he's referring. Well, the main thing is that well, it's not yet on the rationale. We will add it definitely. But the main thing is that with this approach of having a contract just being the owner, it's limiting because it will be just one level. While with this nesting, you can have as many levels as you want, or as long as gas is reasonable. So you can have, for instance, one of the samples we have is like you have a king, which is an NFT, which owns a kingdom, which is another NFT, and this kingdom may have different lands, which are also NFTs, and this land may have soldiers, which are also NFTs, and so on. So, or also for gaming, like you have an item which owns its armor and weapons, and it's different to just having in a different contract because it like this relationship is uh, stated on chain directly. Uh, And as a standard, it's something like any NFT could be nested into any other NFT as long as it implements this interface. So it's not just for a custom use. And I guess I will have to tell that to
Got it.
Sam also. But thanks, Victor.
While we are waiting, I know Victor is also a very active reviewer and is proposed for an EIP editor in upcoming EIP meeting. I would love to have your feedback or maybe thoughts if you have any for the next proposal, which is here, which is 6051. Stephen, I would like to get back on proposal 6059 when Sam is back. But in the essence of time, we can probably move on and get feedback for the next proposal, which is in the draft, if that's fine.
Sure.
Sounds good. Let me pull the link. Can you put the link into the chat room?
Yes, I can do that for you. Paste. Here it is. I don't see Sam online, so I'm assuming something went wrong with his internet or like that. So yeah, maybe we can continue with it. Victor, would it be possible for you to screen share?
Me? Okay.
Oh, Victor, Victor Show.
You're asking about Victor, right? Okay.
Yeah.
Yeah, I can share. Let me use my let me jump to my computer to connect to
Yeah,
people.
sure. Stephen, you did mention that the team has experience with another proposal. May we know the number again, please?
Yeah, it's 5773. It was just
Okay.
merged last week.
Oh, that's nice.
So, yeah.
Awesome. Cool.
Okay. Can you see my?
Yes, we can see your screen.
Yes.
For some reason, I'm hearing myself. The Zoom is having something
Do
wrong.
you have your phone Zoom on as well?
Let me quit my.
He also jumped.
Can you hear me?
Yeah, we can.
Yeah.
Okay.
You are now muted, Victor.
I can see the screen, but cannot hear you.
When I use my screen, I cannot. I seems like I cannot connect audioly. That's weird.
Oh,
Let's try again. I mean, this is weird.
I mean, I can share screen if that's helpful, but I may not be able to scroll
is it-
along. Yes, it's working.
Is
both.
it work? Okay, got it. Alrighty. Okay,
Yeah.
finally. Yeah, so this EIP is proposing a private key encapsulation. It's trying to encapsulate a private key.
mhm.
What it does is encapsulate a PIP so it can locate in another application without providing the seed. Let me see what it is proposing. Core algorithms. And it has requests. Okay. Are you proposing an interface or are you proposing how application works together, meaning like smart contract works together?
It's more like an interface. For example, if you have a MetaMask on the browser as a browser extension, then maybe when you send a request like this, and then if it MetaMask supports this, it can be, the function can be called.
Okay, so the first thing I think I will ask about is consider using interface category that is applying
Mhm.
for example, if you see the JSON RPC are all categorized as interfaces. There's 4 layers. The first layer being the bottom layer being core, which is consensus plus the execution. And then the second layer is a network, which is like how we spread the spread all the transactions and then like gossip network. And then third layer is usually about how JSON RPCs and other RPC calls are scheduled. And it seems like by just reading very briefly, I might be wrong. It looks like it's at least what like look like here is about proposing some new ETH domain ETH namespace interface. So consider that first. That's what I would suggest. And then second, let me see.
Mhm.
So are we doing? Is this an algorithm trying to do the private key exchange? The process.
It's actually, there is a key agreement, but then the private key is not exchanged, is simply encrypted so that the other party can decrypt.
Okay, okay. Let me think about it. You're trying to encrypt a private key and then let the other side of it decrypt it.
Yes.
Uh, Combines CEI. Is this a particular
Yeah, that's a
key exchange
elliptic
algorithm?
curve integrated
Oh, it,
encryption scheme. Yeah,
okay,
that's
interesting. Yeah, I see. That's the abbreviation of that. Yeah, I know that it's very hard for us to put a link here. I would generally hope, my personal opinion, is that things like that be at least spelled out. Because like if people first time see it here, they might not know what you're referring to as what you're referring to, and so spell out when you use a acronym when at the first time in a text would be a good idea.
all
And
right.
I will advocate linking it externally, but our current editorial policy doesn't allow us to link here. So if you have
Yes.
additional if you have it, I guess you might have tried to link it. Let me see. Yeah. Anyway, so but at least explain them and then put some relevant explanation in would be helpful.
All right.
Sam just tweeted that there is internet down
Oh, I'm
in his
back now.
area. Oh, you're back.
Okay.
Thank you, Sam.
All right.
No worries.
Give it back to Sam.
No, feel free to continue. Like, absolutely fine just watching for a bit.
Okay. Yeah, I'm just hey Sam, you are an advocate for non-linking, and then I just have this authors putting in ECIES, and I was hoping this isn't a text that having a link would be a good idea to kind of give more context. But for now, given our policy, I'm suggesting the author to adding to spell out the ECIES for the first time and provide relevant explanation.
Yeah. Yeah, that's a debate I am having with Sam right now. And so this is working on as a key exchange. And then let me trying to understand what the key exchange component parties are you trying to enable? Like what the security model are you trying to kind of set up? For example, who is the intended sender and intended receiver, and then who do you assume have access to the communication channel? Do you assume the adversary will have access to the communication channel? I think it's something that I will be looking for in the next step. So this is an algorithm, very standard of encrypting, encapsulating private key. But let me see if you're trying to invent something new here. Be encapsulate. Authenticating. Is this?
Yeah, actually,
Is a
all
typo?
the elements are just a standard matured algorithm or protocols like ECDH, HKDF, or authentication encryption. That's ASGCM or something like.
Okay, yeah. By the way, this is a typo.
Oh yes, thank you.
Yeah, because I'm trying to figure out what the EN encryption is. Okay, now assuming you are able to do the exchange it, I wonder if there is any man in the middle attack ability here. So
Yeah, there is a
you
signature. Yeah, if you use look at number 2.
number 2, or are you? Can you tell line number?
46, 46.
36. Okay. Ephemeral recipient key are base
Yeah,
points.
maybe, yeah, optionally I could be signed.
Why does signing help ensuring the confidentiality of the key here? I'm trying to understand.
Confidentiality is achieved by encryption. Where I think when we talk about the man-in-the-middle attack, we are talking about if
Oh,
recipient public key is to be trusted or not, right? So
I see. Yeah, basically means the receiver has signed off the have authenticated the response, right?
mhm.
Okay. All right. So this is key exchange. Now you're defining a key exchange, and then now there's the network communication process. You define this request with the method, with the version, with the signer private key.
No, it's a public key.
Signer public key. Okay. Reasonable. Must generate random security private. Let me see what the response. Did you specify? I think at this section, it is ideal that you also specify the format of the response. This is the input parameter, right?
Yeah.
You mentioned the return value is R. This is this is mathematic representation. At this section, I think you start entering the process of describing what the interface look like. So I would suggest also suggest putting in the interface the response format. Right?
All right.
Does that make sense?
Yeah. Yeah.
And for things like version and sign and public key, this is a public key, right? Are you looking for the general standard ECDSA public key, and then, oh yeah, I think you would need to, this is an editorial question for you. The technical choice you make is that you have, is this an example or is this the selection? Wait, that's a shard. So basically the question I have for you is, you should specify let me see if you already did, the length of the key, the length of the version, and of course the length of the public key is relevant to the particular EC, the field, the space that you pick,
Yeah,
right?
this is
EC
specified later in the spec. So
in the version.
yeah, we have the version we
Version
have two
table.
options. One is the elliptic curve. We have two options, and then the authenticated encryption we have three options.
Okay, got it. Wow, I just realized this is a very lengthy, detailed.
Yeah, I think
Yeah, that's great.
maybe we should move a little bit earlier.
Yeah, no worries. I'm going to give some general feedback. This is a very long one. We probably need to also take some more time, either
Yeah.
offline or after. But yeah, this is great. Specify the length of version and okay, and then
what do you mean length of version? If it's just a string.
Yeah, so let's say if your version is when you communicate that there is going to be a version string, you either say that okay, our string is several bytes, right? Our version is represented by a number which is separate bytes, and then we are here going to use a hex string or any mathematical representation. Yeah, basically just communicate the data type. Data type and size. How about that? So that reader can understand what you're referring to. Like if it's a string, I'm assuming in our use case is usually because it's a hex string representing some bytes number.
Yeah,
right?
this is
Like,
specified later.
oh yeah, then if so you're using how many? They'll differ from by each one, right? Okay, yeah, because you want to make it flexible to allow different encapsulation.
Yes.
Yeah, I think it's worthy of mentioning that you either specify here what is allowable or mention it will be specified in which following sections. Like, for example, you will have a dedicated section for all the versions that's considered today. And then in that table, what each kind of what will look like. How about does that is that does that make sense?
Yeah, I think I will point the readers to the later session because they are specified later in the spec.
Right. That's great. Yeah. Let me just put it here. Cool. Implementation must generate as a security sender R2 send request the sender to encapsulate the private key. Request to sender. And usually these requests are, I'm trying to imagine like who is like in real use case. Can you explain to me, help me understand in real use cases, who are your intended sender and who are intended receiver in a typical use case, in targeted major targeted use cases?
Yeah, sender is maybe like a hardware wallet, and then you have a C then you can derive many private keys and addresses. And the recipient, the receiver, it could be a messenger application or some hot wallet. So you can extract one of your private key from your hardware wallet to your hot wallet, so that it's more convenient. That's one of the cases.
I see. That's helpful. I see. Yeah, that helps a lot. I think describing them in deep motivation could be helpful. Oh yeah, you did. Cool. Yeah, that helps a lot. Putting in the context. Where is OOB being mentioned? OOB. Oh, this is the out-of-bound data. Yeah, I would see.
It's mentioned earlier. Yeah, in the code algorithm part.
Out-of-bound data. Okay, got it. Yeah, makes sense. I thought I would probably put more time into reading this. I'm kind of reviewed 1/3 of it. I'm probably put more time into the other thing, but for the sake of time, I guess I'll pause here and then see what Sam thinks and what Podrick thinks. Should we continue reviewing this particular EIP? Should we give it back to Sam, or what should we do here? What's your preference?
If we have other,
go ahead.
So do we have authors for other EIPs here, or?
Yeah, we do have for one more, 5851.
Okay.
Yeah, Sam, do you want to take it back?
Sure. I think this one is quite long. I think it'd be best if we switch to a different one just to get some variety, and then yeah, if everyone's okay with that.
Sounds.
Yeah, Sam, there was a pending question you were asking. So I don't know if you want that answer now, or we can add it to the rationale later and you just review it.
Oh, we can do it. We can do it offline.
Okay.
I'll just ask you again on your discussion thread.
Okay.
So the number is 5851. I have shared link here in the chat.
There we go. Okay. So this one has a Panda pip review. There's a lot of Panda pip review. All right. Interface for signing, validating identities using zero-knowledge proofs. Okay. Let's verify. Okay. All right. Interface for signing, validating. This EIP is an interface for KYC validation of entities. So, KYC verification of entities using decentralized identifiers, DID, with abstract on-chain conditions. Interface allows identity orchestrators to assign identity certificates such as soulbound tokens. Tokens, these certificates, schemes. Okay. Interface for using decentralized identifiers with abstract on-chain conditions. Okay, so I feel like the abstract's a little too light on details here. I don't feel like I get a sense for what zero knowledge brings to the table for this. I don't think it goes into enough detail about who'd be assigning these certificates and who'd be verifying them. So a little bit more information about like is involved.
So we had explained it afterwards with a diagram and workflow, but that has we have to also give brief detail in abstract. Is that the case?
Yeah, exactly. Like I want to be able to read the abstract and kind of know what's going on. And that does. Okay. On-chain verification is increasingly important across Web3, given organization of finance. Yeah, so it's good that you define it here. I just think you should define it the first time you use an initialism. So just move this little blob up to the abstract, and it'll be fine. Send proposals, which have laws for producers. This will resolve the challenges not being addressed by other standards by defining the optimal functional interfaces that defines the identity. There's something weird with that sentence. What's going on? Okay, so thus we resolve the challenges not being addressed by other standards by defining the optimal functional interfaces that defines the identity issue. Should probably be that allows the identity issuer to validate the Web2 base, on-chain along with
we basically create an attestation. So I wanted to basically summarize here that the way to create an attestation, which is of a Web2 based verification on Web3, on-chain verification. So, and then using
yeah, yeah. Yeah, sorry. I was just trying to figure out like this word. I think is just the wrong word choice. And I think it makes sense what's going. Like I think I kind of get the idea of what the EIP is. Yeah. So two. So do you need 5192 style soulbound tokens for this to work, or are they like? Is it just you're mentioning them here for interest's sake?
For reference purposes, yes.
Yeah. Okay. So I don't think 5192 is probably. Oh, it's okay. So then never mind. But it should be a capital T. Okay. New customer standard. It should be plural. Are the set of minimum viable conditions that financial services providers have to satisfy in order to access the services? So in Web3, Web3 this really teaches it. Yeah, okay. Okay. 92 represented the self-sovereign family and then for providing security. Okay. Function to validate if the address verifying is the holder of the SBT defined by the token SB. Okay. And then we want to go back to where did that go? So then tokens 5192. Okay, so this is an extension of 721. It already has owner of, and then
we refer the SBT ID as a mapping, which is being instantiated by the standard. They will map to this ID with this SBT token. So
run that by me again. So what is different from is verified and owner of?
So is verified is just modify a function that has to be called by any entity to verify whether the holder of this SBT. So if someone wants to use the services, so this function will validate that the address which holds this SBT with this token ID. In order to validate is KYC.
Okay, so I'm still not entirely sure. So is the SBT issued to people who aren't verified?
No, it's issued to the people who are verified, who are given identity by the administrator. And then the other, let's say, service who wants to use this identity as verification, they will they will create a modifier on the functions. Let's say I want to access to the liquidity pool in Uniswap. So add liquidity pool, this function will have this modifier function, which will check whether the caller of this function, the address of this function has this token ID or not. Token or not, basically. Is the actual owner of this NFT or not? Yes. So it's very, so the owner of, yeah, I mean, there are two different terms. It just gives the Boolean result.
Okay, and so you're saying you have the identity provider gives an SBT token to me, let's say, right? And then I want to access your service, which is like a Uniswap pool. Is that kind of the thing you're saying? And then if you get to choose whether the holder of the token that I have is allowed to access your pool, or
Indeed, yes.
okay. Okay. Okay, where is... So why? So the requirements are actually like stored on chain,
Indeed.
but they aren't executed on chain.
No, they will be just referred on chain by the integrators of this KYC service. So they can, from their side, define off-chain via IPFS that these are the validators they want to verify, and then they will compare it with the requirement structure which is presented on chain. But
Okay,
we will have
did
to.
you did just say IPFS, right?
Sorry.
Did you just say like it'd be on IPFS or?
Yeah, it can be on IPFS for optimizing the storage. So I will mention that.
Okay, because like if you're doing it the same way as like 721 metadata, that might be useful, where it's just like a URI to the requirements, and then that URI could be a like IPFS link or something like that. Just because it seems like a lot of information to store on chain for something that's not going to be used on chain. I'm not sure. Yeah.
Yes, sure. I will mention that.
Okay. So where does this zero knowledge stuff actually come into this?
Sorry.
where does the zero knowledge like proof come into this? Where is that verified on chain? Is that verified off chain? How does that work?
Based upon the type of protocol, if we need initial creation of the shared proof string, we will have to use that. So it's agnostic to, it can be ZK star, it can be any other category of protocol. So we are not for example, we have used Merkle roots to we will store the Merkle root by creating the hashes of your personal let's say address and other details. And then once you have to prove is you just have in the metadata only the hashes of the certain leaves, and then it will recompute whether this information on chain will give the same rule Merkle root as initialized by the administrator.
Okay, so how does that interact with the contract on chain? So where do you actually store the information that you need for the ZK proofs and everything?
It will be stored on the requirement structure, all the proofs, leaves that you want to verify.
Okay.
And then there will be a mapping corresponding to the each address and corresponding to what its Merkle root is all identity data and user data. So we just use the, let's say, same mechanism that is used for whitelisting on-chain.
Okay. I'm probably gonna have to give this like a couple more reads through. I'm not super familiar with the ZK stuff. And I think we're almost out of time today, but I'll add this to my list of things to pay attention to, and I'll get back to you with the rest of my feedback.
Maybe I can add a comment. I mean, we basically like for any ID property, we just slice them into different attributes. So all these ID attributes are kind of fragmented, and all this value will be only Boolean value. So it's basically provide a certificate to attest to this person. He hold a ID. He's like over 18 or 21. He's in this section, this or not, and all this will be totally with offline encryption files, and according to the truth already explained with the metadata structure storage. I'm not sure if I made this clear.
Yeah, so you rephrase that the process that basically we follow.
Yeah.
To generate this credentials. Okay. So
yeah,
Sam,
so I think my concern here, just to kind of clear this up a little bit, I think a lot of this information is probably going to be in your reference implementation. And you know, it's probably just that I'm not reading this in depth enough. So like I said, I'll give it another read and then I'll get back to you.
Sure. So for the drafts, we need to let's say brush up all the feedback that you have given now, apart from grammatical and other issues, and then also kind of go in much more details about how we store the requirement structure, and also how it refers to the zero knowledge proofs.
How you store it probably isn't, like, if you're pointing to a URL, I mean, that would probably be what I would suggest. But if you're going to store it on chain, like what's a good way to put this? It's like the EIP should only expose the interface. It shouldn't it shouldn't specify the implementation details. So yeah, just be careful not to get too in the weeds about how your particular implementation does it. But yeah, I think that's good so far. And like I said, I'll get back to you with some more feedback on it.
Sounds good. Thanks.
All right. Thank you so much. Thank you, Sam. Thank you, Victor. Sam, Victor, if you guys get time, there are 3 proposals for moving into final status. So if that can be looked offline, that would be nice to have. And yeah, see you all in 2 weeks. Thank you, everyone, for joining us today.
Thanks, Pooja. Thanks, everyone.